So let's talk about something fascinating happening inside Meta. They're now using AI to write the code for other AIs. And it's all to solve this massive, hidden problem that was threatening to slow down pretty much everything you see and do on their platforms.
To really get what's going on here, you first have to wrap your head around the sheer scale of Meta's operation. I mean, it's almost impossible to comprehend. We're not talking about a server rack in a closet. We're talking about global data centers that drink hundreds of megawatts of power, all just to run AI. And what are those data centers doing with all that power? This, every single day. They are handling hundreds of trillions of AI inferences. Now, an inference is just a tiny decision, like ranking an ad, recommending the next video for you to watch, or personalizing some content. It is a constant, unbelievable storm of computation.
Okay, but here's where it gets really cool. Every single one of those trillions of decisions is powered by these tiny, super specialized bits of code called kernels. The best way to think of a kernel is like a very specific recipe. It's a recipe that tells the computer chip exactly how to do one simple task, like one math problem, with the absolute most extreme speed possible. But, and there's always a but, this whole system of specialized recipes created a huge hidden bottleneck. It's a problem that they call the curse of dimensionality, and it was basically threatening to create a system-wide traffic jam, slowing down the entire company's pace of innovation. In this curse, it wasn't just one single thing. No, it was like a three-headed monster. You had this huge diversity in hardware, a huge diversity in AI models, and a huge diversity in all those little kernel recipes needed to connect the two. You put all three together, and you've got a genuine scalability crisis on your hands. So let's start with the hardware. Meta doesn't just use one kind of chip. They've got a whole fleet of different AI accelerators, NVIDIA GPUs, AMD GPUs, and they even have their own custom-built chips, like one called MTI. Now here's the kicker. A recipe, a kernel, written for an NVIDIA chip is completely useless on an AMD chip or on their MTI chip. They have totally different architectures, like trying to use a gas stove recipe on a microwave. And this is where the numbers just get absolutely bananas. Get this. Meta has over 1,500 different AI models running in production. Each of those models needs around 200 unique kernel recipes to work right. And every single one of those recipes had to be manually rewritten and fine-tuned by a super specialized expert engineer for every single type of hardware. This wasn't just slow, it was becoming economically impossible to keep up.
So what was the real-world cost of this nightmare? Well, if just one of those little kernel recipes was missing for a specific chip, the whole system had to take a detour. It had to send that one little calculation off to a slower, general-purpose CPU. That detour adds a 10 to 20 millisecond traffic jam to the whole process. Now, that might not sound like a lot, but when you're doing this trillions of times a day, it's a massive architectural tax that wastes a ton of energy and just makes the user experience worse.
So, how did Meta solve this three-headed monster of a problem? Well, they didn't just hire more coders. No, they built an AI to be the coders. And this is the hero of our story, a system called KernelEvolve.
Now, KernelEvolve is not just some simple code generator that spits out text. It's what's known as an agentic AI. And what that really means is that it acts like an autonomous software engineer. It can plan what it needs to do, it can use a whole bunch of programming tools, it can test its own work, and it learns from its own mistakes, all without a human needing to hold its hand.
You know, the absolute best way to think about it is like an AI master chef. You can just give it a task, right? You say, hey, I need you to make a dot product. And then you tell it what kind of kitchen it's working in. Is it an NVIDIA kitchen, an AMD kitchen, or that custom MTIA kitchen? And what it does is it invents a brand new, perfectly optimized recipe from scratch just for that kitchen's unique tools. And it does it in minutes or hours instead of weeks. Okay, so this AI master chef sounds pretty amazing, right? But how does it actually do it? How does it come up with these perfect, award-winning recipes for code? What's going on under the hood? Well, at its core, it uses this really powerful but actually kind of simple process called a tree search. Think of it as a relentless loop of trial and error. So first, it just generates a possible version of the code. Second, it compiles and runs that code on the actual physical hardware chip. Third, it analyzes all the performance data, any error reports. And fourth, and this is the magic part, it learns from those results and immediately goes back to step one to generate a better version. It just does this over and over and over thousands of times, exploring thousands of different possibilities. So to make this loop so effective, KernelEvolve has a few secret weapons.
It's got that intelligent tree search to explore all the options. It has a full set of automated software engineering tools for testing and debugging. But its most important weapon is what's called a persistent knowledge base, basically a library that it builds and maintains for itself, full of hardware secrets, optimization tricks, and all the weird little rules for every single chip.
And this is the real breakthrough. Because of this knowledge base that it can read and learn from on the fly, KernelEvolve can write expert-level code for brand new, secret, proprietary hardware, like Meta's own MTIA chip, a chip that it had literally never seen in its original training data. It is teaching itself how to code for secret hardware. It's just wild.
So, okay, we've got this incredible AI. What did all of this actually achieve in the real world? Well, the impact was nothing short of dramatic. It completely changed the economics of AI development at Meta.
Just take a look at the old way versus the new way. A single one of these kernels used to take a human expert anywhere from 2 to 8 weeks to write and perfect. KernelEvolve does the same job and often does it better in just a few hours of completely automated work. That is an insane leap in efficiency.
And it's not just about saving time for the engineers. The code that the AI writes is often so much faster. For a key part of Llama 3.1, it got a 4.6 times speed up. For some really critical data processing tasks, it was over 9 times faster. And for one specific task on Meta's own MTIA chip, it generated code that was an incredible 17 times faster than the baseline. 17 times.
And this brings us to what I think is the most important takeaway, and it comes straight from the researchers themselves. The AI isn't just matching what humans or traditional software can do anymore. For these really specific, critical jobs, the AI is now exceeding them. It's finding new ways to optimize things that were just too complex or time-consuming for a person to ever find.
And that just leaves us with this one fascinating final thought. We started with this idea of AI building AI. We've seen an AI agent learn the secret languages of computer chips and solve this crippling bottleneck for one of the biggest tech companies on the planet. So if AI can now automate and optimize this level of deep, specialized engineering, what other huge, complex, human-gated problem is it going to solve next?